Hi guys, 16.2, arc length and radian measure, geometry. Okay, the essential question, how do you find the length of an arc? So we're still involving ourselves with circles here. The answer is that the arc length S of an arc with measure of some angle, okay, some degree, and a radius R is given by the formula M. So however many arc measures degrees that you get, divided by 360, because there's 360 degrees in a circle, times 2 pi. So let's take a look at what I'm talking about here. So let's say, well, first things first, we have a situation here. We're going back to the definition of an arc. It's an unbroken part of a circle consisting of 2 points, called the endpoints, and all the points on the circle are between them. So basically, here's your arc from A to B. Okay. Now, the arc length is understood to be the distance along the circular arc measure in linear units, such as feet, centimeters. So now we're going to find the length of that arc, the one I just highlighted, in actual, in this case, centimeters. Okay, so we're going to go ahead and apply this theory. We have 360 degrees. Okay, first things first. M, our measure, that is the worst M my touchscreen has ever given me. That is scary. M degrees is what they give us here, 60 degrees. So we're going to apply our formula. We have M divided by 360 degrees, just as the essential questions answer says, times 2 pi times r. Okay, because r is our radius, and we're working with a certain radius now. Okay, so this is the formula for arc length. Arc length. Okay, that is the takeaway. That is the formula to use when trying to find arc length. Okay, there are 2 things you need to know. What is your M? In this case, it's 60. And then what is your radius, which they say is 9. Okay, so there's 2 things you have to find in order to apply this formula, and then just plug it in, substitute, and then start computating, and you'll get your answer. So let's look at my situation here. Okay, M was 60. Okay, so I'm just substituting in for my equation. There's again 360 degrees in a circle times 2 pi times r, which is just 9 centimeters. Okay, so we can go ahead and reduce. All right, 60 divided by 360, we can reduce. That just becomes 6 over 36, which is technically just 1 over 6. Okay, times, well, let's see, we can go ahead and take care of the 9 and the 2. 2 times 9 is 18, which is just 18 pi. And let's see, 18 times 1/6 is the same as saying 18 divided by 6, which is just 3 pi. And then pi is 3.14. And you should probably use a calculator because, again, you're looking for a certain unit of measurement, in this case centimeters. So 3 times pi will get you an approximate answer. So the arc length, okay, for AB okay, for the purple part, is approximately, sorry, I almost said equals there, and let me go ahead and erase that because that is ugly. Wow, touchscreen epic fail. I'm literally building a computer to make sure I don't have to deal with this nonsense anymore. If you haven't ever built a computer, it is fun. Approximately, wow, that is the worst approximate. Sorry guys, epic fail all around. There we go, there we go. Approximately 9.4247, let's round to the nearest tenth, okay? Oh, and that's what they say. Okay, centimeters. Okay, so that'll be the answer for this example. Okay. So basically, remember, we have two things to find. What is the angle measurement that they give us for that arc length? And then what's the radius of the circle that it exists on? Okay. And then just substitute, plug and chug, and you're all set. So just to let you know, pi is the same as saying 180 degrees. 2 pi is 360 degrees. And you're going to see that with radian conversions coming up soon. But there's a couple problems like this on your homework. All right, so the arc length formula, again, just like how I showed you earlier, is represented as this equation. Okay, so that is the entire setup. All right, so application. So if we're looking at this first example, and I kind of gave you a more accurate example to your homework just earlier, you have a clock face, and the minute hand is 10 inches long. So basically right away, they're go ahead and telling you that this minute hand, okay, is 10 inches. Well, that's your radius. Okay, they just gave you your radius. Okay, so that is your radius. That's R. Okay, so you have R. That's one of our components that we need to know. Good. To the nearest tenth of an inch. Okay, how far does the tip of the minute hand travel as the time progresses from 12 to 12:15? So minute hands go all the way around, right, for 60 minutes. Right? But we're only talking about 15 minutes. Okay, we're talking from, let me try a different color here. Green shirt, why not? They're only talking about 15 minutes, okay? But we do know that this thing goes all the way around for 60 minutes. So just like the scenario where you only have a certain arc measurement, for this one, same thing. You only have 15 minutes out of 60. So this is how they set it up. They take your arc measure, which is, in this case, 15 minutes out of the 60. So they divide it. They give you a nice little fraction when you do that. So basically, if you were just thinking about circles only, the 1/4 of 360 is just 9 degrees. Okay, and you can even see that visually right here. That's a 90-degree angle, okay, for 15 minutes out of 360. So when you apply it in sense of circles, it's just going to be 90 degrees out of the 360. So 90 over 360 times 2 pi times 10 inches, and you should get 5 pi, okay? Once you get that, 5 times pi in your calculator will give you an approximate answer of 15.7 inches. So first things first, you have to kind of understand, well, how much is 15 minutes out of 90 minutes, or 60 minutes? So you have to kind of think about the context of your situation, then apply it into the sense of the circle. So use the formula, okay, substitute, plug in your calculator to simplify, and you're going to get an approximate answer. All right, your turn. The minute hand of a clock is 6 inches long. Okay, so there's your radius. Awesome. To the nearest tenth of an inch, how far does the tip of the minute hand travel as time progresses from 12 to 12:30? So now, here's your clock. I know that is the worst circle ever. Okay, slightly better. So there's 12 o'clock, but now it's going to travel to 12:30. That is how many degrees out of that circle? Looks like half. So what is half of a circle? So that part is going to go right here. You already have your radius, should be going in here, and then plug it into your calculator. Okay, so we already know that 30 minutes out of 60 minutes is 1/2. So the initial angle, so what's half of 360 degrees, right? And that's basically what I asked you with this drawing right here. Okay, what angle is that? So whatever angle that is, plug it in right here. Okay, you already have your radius, plug and chug, and don't forget your answers in inches. So that's your turn. Let me know when you get the answer. All right, buddy time. So basically the math works the same way even when the radius changes, and they are proportional every time. So what I want you to practice doing right now is notice how for when the radius is 1, okay, well, we're still working with a right angle, 90 degrees. So they're applying this math. So you're going to do 90 divided by 360 times 2 pi, whatever radius you're using, okay, to find your answer in terms of pi, which is also known as radians. And then you're going to use your calculator to get the decimal answer, okay, which is what we kind of call degrees in the business. And we'll get to that as you evolve. So you're just going to do these 4 different types of problems with your buddy, okay? And then, of course, I'll draw a stick. I'll probably have this up on the whiteboard on a projection, and that way you guys can see what's going on. For some odd reason, my keyboard is not working. Wonderful. Oh, there we go. All right, so converting radian measure. The constant of proportionality of the proportional relationship is whatever the arc length is divided by 360 times 2 pi. Now, this constant of proportionality is defined as radian measure of angle. So, here's an example. We have 180 degrees, and we're going to convert it into radians. That means by the time we're done, we're just going to have, something to do with pi, all right? So, to convert it, m is going to be 180. So we're going to plug it into this equation, okay? Once we do that, okay, 180 divided by 360 is just 1/2. 1/2 times 2 is just 1, and all you're left with is 1 pi radians. So basically you're just using this conversion ratio to find your radian measure. So your turn. You have 60 degrees, and you have to convert it to radian measures. So again, you're going to be applying this conversion ratio. M is just that, 60. Okay? Plug it in, and you'll find your answer in radians. Leave it to where you have something to do with pi. Okay? Your answer has to have pi involved for radians. Here's your homework, page 867, numbers 1 through 3, 5 through 7, and 13 through 20. It's It's pretty important, guys. All right, this content just keeps on going for like the next month or two. Okay, so basically for the rest of the year. All right, if you have any questions, let me know. Good luck.